Welcome. Today, we stand on the precipice of a new era. We're here to talk about innovation and opportunity. How is this even Purin? How is this even possible? That 800-ton steel weight is swinging right now because the wind is trying to snap this tower. They deliberately left entire floors completely empty, just so the wind can blast straight through. Hi there! We're introducing a new feature where I can read this aloud in a natural, human-like voice. 200 steel anchors are drilled into bedrock. They don't hold it up, they pull it down. 7 years, a gap between buildings, the world's thinnest skyscraper. This is how it happens. Steinway Hall is where Glenn Gould plays his last concert. They cannot touch one stone of it. They cannot touch one stone of it. The only buildable land sits in a 57-foot strip.
So this highlighted section here is where we need to focus the additional support structure. It's essential for the revised plan.
It tries to flip it over.
57th Street is a wind tunnel between two avenues. Anchors hold it down, shear walls hold it up, the damper kills the shaking. The shovel hits the ground, 12 inches away, a fragile 90-year-old landmark. This is the danger. Under every building in Midtown Manhattan, solid bedrock. The drill is fighting through 30 feet of it. But there is one massive problem. Steinway Hall's 90-year-old footings sit directly in the foundation zone. The new caissons thread between 90-year-old footings. Old and new foundations lock together, permanently. The drill goes 100 feet into solid Manhattan schist that is 10 stories below the street. That rebar cage is 100 feet long. They lower it into the ground hole, then pour concrete. Wait until you hear this. These anchors don't hold it up, they hold it down. 30 meters of steel tendon bonded to rock with epoxy. That anchor is now Manhattan. The drill just hits a fracture in the bedrock. The anchor is off alignment. The grout won't hold. Seal the fracture with pressurized grout, let it cure. Re-drill through the sealed rock, start again. 200 anchors, 600 kips each, pinned to bedrock, held down before it is built up. The building tries to lift, the rock says no. That is the entire system. 36 inches thick, 57 feet wide, 1,428 feet tall, the thinnest shear wall ever at this height. $5.5 million feet of rebar going into these two walls, enough to circle Manhattan 200 times. One floor every 5 days. The formwork climbs itself. The concrete sets. The wall grows.
36 inches at the bottom, 16 at the top. Wind moment is biggest at the base.
14,000 pounds per square inch concrete placed in 12-inch lifts. Internal vibrator every 18 inches. No voids allowed. The formwork is cracking under 14,000 pounds per square inch fresh concrete. If that panel blows, the pour stops forever.
Emergency tiebacks welded in 20 minutes. The form holds. The pour resumes from exactly where it stopped. Core plus 2 shear walls equals 1 giant I-beam, 57 feet wide. That is it.
The concrete gets weaker as the building rises because the wind forces do too. Every floor calculated.
At floors 38 and 70, outrigger walls tie both shear walls together. 2 walls become 1.
This outrigger connects both shear walls. The building now acts 180 feet wide instead of 57.
The piano showroom is open above. Below it, micropile rigs are working. Nobody upstairs hears anything.
Walk 1 block north and this 1,000-foot tower disappears. It is so thin it hides behind buildings. 0.8-inch lean at floor 22. On a 57-foot tower that compounds floor by floor. Correct it now.
2 lifts, 0.4 inches south each time. The wall is straight again by floor 25. Crisis over.
Here is the crazy part. 2 entire floors are left completely open. Wind passes through.
Stand here. The wind goes through the building instead of around it. That stops shaking.
April 2019. The concrete tops out at floor 85. A 57-foot blade now visible from New Jersey.
1.1 inches of deviation over 435 meters. On a 57-foot wide building, that is the limit of precision.
Floor 36, 14,000 psi, 4 meters deep. 1 shot. You cannot fix an outrigger wall twice.
A 200-ton steel truss is spinning in the wind above Manhattan. 4 ironworkers catch it by hand.
The outrigger bolts onto it today. Perfect fit. The bolt holes do not align. The embed shifted 0.6 inches 2 years ago. Slotted holes take the 0.6-inch offset. Torque to 880 foot-pounds. Accepted. It becomes permanent.
Every wind force from 60 floors above passes through this one truss.
The spire is an aircraft navigation reference. The FAA requires it at this exact height and position. Sub-zero temperatures at 1,200 feet. Ironworkers bolt spire sections by hand. Welcome to Billionaire's Row.
14 elevators in a 57-foot wide tower. 2 of them open directly into the apartment. No corridor, ever.
An 800-ton steel box inside the top of a 57-foot tower, ready to swing. January 2021, 78 miles per hour gusts. The building swings 8 inches at floor 75, and the damper swings back.
Some wind speeds make this building vibrate like a tuning fork. The damper matches that frequency.
9 miles from the George Washington Bridge, you can see this 57-foot needle against the sky. Incredible.